In this video, I'll be working through the question you see on the screen here from 2025 Leaving Cert Ordinary Level Paper 1. I'm going to try and show you how to do the question, not just the solution. So pause and rewatch certain parts of the video if you need to. If you're looking for a different question from this paper or a different paper entirely, have a look at the description below. You should be able to find a playlist there or search around on my channel. Okay, let's get into the maths. In question 2, we're dealing with complex numbers. I would say students are most terrified by complex numbers, but you really shouldn't be, because they ask the same 4 or 5 different questions every year. So you should be able to get full marks on this question every year. It doesn't change all that much. With that in mind, part A, they give you 3 different complex numbers here, and they give you an argon diagram. They nearly always will give you an argon diagram. They want you to put these numbers on the diagram, or sometimes they want you to take the numbers from the diagram. In this case, we're drawing them in. They've already done Z1 for you. So let's say -1 real numbers and +2 imaginary numbers. That's this is the real axis, and this is the imaginary axis here. So we just go -1 on the real axis, that's here, and +2 on the imaginary axis. All that means here. They've done that for us. We do that for the next two. +2 real, that's 1, 2. I don't have the numbers in, save myself time. And +3 on the imaginary. So it's 2, 3. That meets over here. There's Z2. And Z3 is 4 minus I. That goes 1, 2, 3, 4, and minus somewhere down around here. That's Z3. That's it for A part 1. Another staple is part 2, where they ask you to get the modulus. So we have a formula for that. Well, let me write Z1 again as -1 plus 2i. So we have a formula for this. It's just the to A and B, I think usually we write it as, it's just the first number here, -1 squared, plus the number in front of the I here, that's a 2 squared, and the square root of that. That's it. I'll do this one. -1 squared is 1, 2 squared is 4, 1 plus 4 is 5, square root of 5. That's the answer. If you don't like doing it that way, there is other ways to do it. The modulus, which will become important in the next part, the modulus is just the distance to the center. So that means we can draw a little triangle there. If I draw that triangle again, that's a length 1 here and a length 2. All they're doing is Pythagoras theorem, this length here, and that's 2 squared, and 1 squared. -1 and 1 squared are the same, really. They both are +1 when you square them, so you get a square root of 5 here. So a couple of ways to do that question. In part 3, they tell us there's some new number, Z4, and they want you to make that up. But they tell you the modulus of Z4 is less than the modulus of Z1. Oh, less than. My notes has greater than, so my notes are wrong. So what does this mean? This means, well, what I just did with the triangle here, Z1, the modulus of Z1 is the length to the middle. So saying something is less than that, it means we're going to be closer to the middle. Another way to do that is to draw a circle here. Square root of 5 would be around here, so let me just try and draw it roughly correctly. I know that's a bit bad. If you literally got a compass and put it to Z1 on your paper, you could draw a circle there. What they're really asking for here is a Z4 to be inside the circle. That's it. Any number inside that circle, any imaginary number inside that circle would be an answer for Z4. So I will just say Z4 is equal to, let's see, 1 plus I. That's 1 plus I. I'm going to put Z4 here. Although you could pick lots of other numbers. Just a few examples would be, I guess, 2 plus 0 I. That'd be a bit tricky, because would you have to write the 0? They wanted it in the form of A plus BI. Another one would be, say, -2, -2 minus I think would fit. That'd be, let's see, -2 here. It looks, on my drawing, it looks like it fit. I'd be safe. I guess to be really safe, you could say 0 plus 0i would definitely be 1 inside that circle. Anyway, I thought I guess that was a little out of the usual of a type of question here, but I thought that was really clever. I guess that's the difference between getting 100% on this question than getting 80%. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Because part B gets back to being a much more standard type of question, you'll probably deal with a division question in the exam. They give you two complex numbers, u and v, and they basically just want you to divide them. U divided by v. What's that going to look like? We can write 4 minus 6i divided by 1 plus I. So how do we do division? Hopefully you've done 10 or 20 of these questions in study. It's students just know to multiply by the conjugate of the bottom. I'll say a little more though. I will say you can multiply any number by 1. 1,000 multiplied by 1 is still 1,000. Minus 8 multiplied by 1 is still minus 8. So we can multiply any number by 1. I'll also then say to make 1 is easy. It's any number divided by itself. So 8 divided by 8, a million divided by a million, 4 divided by 4. Or in this case, we're going to do 1 minus I divided by 1 minus I. So what we've done here is not done anything. A number divided by itself is 1. 1 multiplied by something doesn't change anything. But the reason we did 1 minus I, the reason we picked the conjugate of the bottom row is what's going to happen in a few moments. So let's just go ahead and multiply this out. 4 by 1, we get 4. 4 by minus I, we get minus 4i. Minus 6i by 1, we get minus 6i. Minus 6i by minus I, 2 minuses make a plus. 6 times 1 makes a 6, and I by I makes an I squared. On the bottom row, we get 1 by 1 is 1. 1 by minus I is minus I. I by plus 1 is plus I. That's the reason, by the way, they cancel each other. And I by minus I is minus, and then I squared. So the reason we picked that conjugate, the minus in the middle here, was because we knew this would destroy these two i's. And then once we remember, let me write it up here in a little box, as a lot of teachers tend to do. I squared is equal to minus 1. That's a very important thing to remember. Everywhere we see an I squared, we can change that to a minus 1. So this top row becomes 4. Let's see, minus 4i minus another 6i's is minus 10i. And we'll change this to plus 6 minus 1, or multiplied by minus 1. So that's minus 6 really. And the bottom row is 1 minus 1. Clean that up again. We get this as minus 6, 4 minus 6. The top row is minus 2, minus 10. I divided by 2 minuses make a plus. 1 plus 1 is 2. That's nearly your answer. 2 goes into both of these. So our final answer is minus 1 minus 5i. And that's it for all of question 2. If you have any follow-up questions on that, again, the tricky part was probably this modulus less than or greater than. But if you have a question about anything I did there, or if I made any mistakes, let me know in the comments below. Do me a favor though and put in a timestamp just so I know where you're talking about. Thank you for watching and have a great day.